Good afternoon, guys. Welcome to our session. Today, we're going to cover the Cisco SD-WAN deployment, what all it takes to actually deploy a Cisco SD-WAN solution. My name is Misbah Rahman. I'm a technical marketing engineer with the Enterprise BU focusing on the Cisco SD-WAN solution. I actually joined Cisco with the Viptela acquisition, so was part of the actual Viptela team, was basically covering the service provider and partner integration with Viptela. So in terms of the agenda, what we're going to talk about today is the detailed steps in terms of what is needed in order to deploy the Viptela solution or the Cisco SD-WAN solution, I must say, how the controller gets deployed, what's the sequence of execution, how the data plane is deployed, and what the policy architecture, how the policy architecture takes place in order to integrate the traffic flow. We're going to cover the security and cloud on-ramp pieces of the solution, how the security is actually integrated into the solution and it's not an afterthought, and what all security feature you can actually implement with the SD-WAN solution. And then cloud on-ramp is one of the critical component of our solution in order to provide customer a seamless access through their WAN infrastructure into the cloud services like infrastructure as a service with AWS and Azure, or software as a service if they want to adopt like Office 365 or any other SaaS-based services. High availability and scale is also one of the critical components. What we have provided is with an architecture which is horizontally scalable. So it would work the same way for a 20, 30 site deployment as it would work for a 1,000 site deployment. So we're going to cover that aspect of the solution as well, how you can deploy a scalable solution and how high availability works in terms of the data plane traffic flow. Migration scenarios is key to the solution because in order to sell the value of Cisco SD-WAN, it's great like all the feature and functionality that it brings to the table. You can convince any of your customer, but the fact of the matter is that the SD-WAN solution still needs to interoperate with the existing infrastructure. You need to provide a seamless path into the brownfield migration where you have the existing MPLS, traditional MPLS SD-WAN WAN running, and now you want to integrate with the Cisco SD-WAN. So we will be covering the best practices in terms of migration, what's the recommended way to migrate a non-SD-WAN environment into the Cisco SD-WAN. And lastly, we're going to cover the hands-on lab. I got like several labs for this session, and we're going to basically make sure that we give the look and feel to you guys as well, how and what it takes in terms of like managing the whole infrastructure, how you bring up the site, bring up the policies and all that. So there's a hands-on lab section to it. In the end, I've kept some time for Q&A, but we can keep it interactive as well. So if any of the Q&A comes during the slide, we can take that during the slide as well. Now, in order to deploy SD-WAN, there are three major steps if you look at it. We got the completely decoupled control plane. The control plane means all the controllers that are needed for the solution. We have three different types of controller, which we're going to go into the details of it, what are the roles and functionality of it. But from a sequence of step perspective, that's the first step into the deployment. You need to have the controller up and running. These controllers are the VMs that can be deployed in a cloud infrastructure. We support AWS and Azure as the cloud offering, or it can be on-prem with KVM, ESX hypervisors. Once you have the controller VMs deployed, they need to securely authenticate each other. So there's the cert management, the way that they authenticate each other, and then there's a whitelist model to it. After this whole secure bring-up is up and running, you have the controllers up and running, ready to accept any data plane traffic. Once the controllers are up and running, you talk about deploying the router at the site. All the config templates can be pre-built into the controller, so whenever the site comes up or a router comes up, the data plane router comes up, it establishes a secure control plane connection with the controller, and one of the controller, the management controller, will push the final configs to the on-site device, and you can have a plug-and-play model in order to bring up a site, which was unheard of in the traditional WAN case. In the traditional WAN case, you have to have a truckloads of gear, ship, You have to have personnel who knows the router config to install it and to bring up the site. We can instantly develop the templates into our management controller, and the devices can just inherit those config. At the same time, even for this data plane, security is a key component, like the secure bring up of these solutions. So we want to make sure that those devices will be authenticated in a two-step process. We have to validate the search, and plus at the same time there's a whitelist model to it. So only the controllers coming from a specific serial file or the serial numbers that they have, that the customers have bought, only those devices will be allowed to make a secure control plane connection with the controller. Once you have those figured out, the third component of the solution is the policy. The policy drives how you can centrally control the routing in your whole infrastructure. You can bring up the data plane, you can bring up the config, but our policy and routing is centralized through our, again, controller mechanism. We can do different types of policy. We can have control policies. We can have data plane policies. We can have app-aware policies. All these policies, we're going to go deep into it, what are those policies are, and how we can use it. Now, from a controller deployment perspective, the three controllers that I mentioned are vManage, vSmart, and the vBond. In terms of the functionality, as the name suggests, the vManage is the management interface, is the GUI interface. It's a one-stop shop for the customer in order to manage, deploy, troubleshoot, and monitor their network. From a day-to-day operation perspective, I do not expect any of the customer going into the vSmart or the vBond to check stuff. All the access will be through a centralized management. It's a single source of truth for the whole environment. After the vManage, there's the vBond. The vBond is the orchestrator, which is the glue that provides and facilitate the connection between the vEdge router and the other controllers. So whenever the device comes up, whenever the vEdge router comes up, only thing that it knows in its config is the address to the vBond. So it will go to the vBond and will say that I'm here, I need to establish control plane connectivity. What are my vSmarts and the vManage? Once the secure connectivity is established with the vBond will forward that here's the vSmart and the vManage that you need to talk to. And once it talks to it, establish a secure control plane connection with it, and then start advertising routes, stats, and everything. So from a connection perspective, the vBond actually helps facilitate all those connectivity. There's not a persistent connection between the vEdge router and the vBond. After it's done establishing connection with the other controller, the connection with the vBond tears down. The last piece is the vSmart. The vSmart is actually the brain of the solution. That's where whole power of the solution comes in. From flexibility, how we can route, how we can create topologies, how we can centrally push data plane policies or an ACL type policy. That's the brain of the solution. I'm sure, like in these SEVT, you'll be hearing about it, that this is like a BGP route reflector on steroids. Because what it does is, from a vEdge perspective or the data plane perspective, the data plane do not, the routers do not establish any peering between them. They only establish the IPsec tunnel in order to forward the traffic. How they want to forward the traffic, that decision comes from the vSmart controller. They will advertise what they own from their site perspective, that this is the routes that I own, this is the WAN interfaces that I have, this is the application or the services that I'm hosting to the vSmart controller. And on the vSmart controller, based on those advertisements, you can define your policies and decide what route to take. Just a quick example before going too deep into it is, let's suppose if you want to do a hub and spoke topology. All your remote sites will advertise a route to the vSmart controller, and the vSmart controller will tell that these routes only needs to be advertised to the data center and not to the remotes. Just from a single policy, you just created a hub and spoke architecture. It could be on a per VRF basis, like on a per site basis, so there's a lot of granularity in that too. And we do have a lab to cover that, to create a hub and spoke through just click of a point and click, and in the end result will be a hub and spoke network. In terms of deployment, there are multiple options. The deployment models are flexible. The Cisco can actually host the controller for no additional cost. We actually host it in a public cloud infrastructure. The reason why we do it is it's a win-win solution for both us and for the customer. For customers do not have to worry about the infrastructure cost to host these VMs. This will be free down to the customer. We will host it. We'll provide the SLAs and everything. For us, the way it helps is from a troubleshooting perspective, and if you want to get into the environment, our TAC will have an easy way to access these devices. It would be ultimately on the customers if they want our support teams to be able to access the devices. But even if we don't have access to it, coming on a WebEx and getting into this environment would be much more easier than getting a VPN access into their environment. So whatever, like from a recommended way perspective, we actually propose customers to be using our public cloud infrastructure as much as we can. And then at the same time, there is an on-prem option too if they want to host it on-prem. Again, perfectly supported design, but again, the customer has to bear the cost of the infrastructure. There's no additional cost than the infrastructure, but customer will have to take care of the uptimes and the SLAs for the on-prem deployments. And again, we already talked about the recommended way in the field when you guys talk to your customer is to go with our cloud infrastructure. Now, from a deployment perspective, there are two models in from a SD-WAN overlay perspective. There are two ways that you can deploy this solution. You can deploy it in a single tenant mode. So every overlay will be dedicated to a single customer. Your customer A, B, C can have their own overlays, can have their own controllers, simply dedicated to them. But at the same time, there's a multi-tenant mode that is supported as well. This becomes handy if a service provider is looking to offer it as a managed service, because they don't want to spin up individual controllers for individual customers. Simply, they can actually operate in a multi-tenant mode. In case of a multi-tenant mode, the vManage and vBond will be completely multi-tenant, shared across different customers. So whenever from a service provider perspective or from a super root user perspective, it will go into the vManage and it can actually drop down, take a look at the number of tenants it has, and can individually dive into each tenant's infrastructure. That will give the information specific to that tenant. Similarly, from a vBond perspective also, there will be a hierarchy in terms of who owns this device. So there is a service provider org name that who is the service provider, and underneath there can be multiple customers. So the vBond and the vManage will be completely multi-tenant. From a vSmart perspective, as I talked about, that this is the brain of the solution. So we want to make sure that the control plane and the overlay routing is dedicated to each customer. It's not like we're creating multiple VRF and calling that VRF a customer. It's still a separate overlay, but the way we provide multi-tenancy at the vSmart level or the controller level is these vSmart can be deployed as a container, but this would be a separate instance per customer so that the overlay is completely separate and not mixed with, the routing is not mixed between the customers. And again, from a deployment perspective, if it's going to be in a public cloud infrastructure, we can host it in AWS, Microsoft Azure, and if it's an on-prem deployment, this will be hosted in KVM or ESXi. So from an automated workflow, like AWS has been more mature. We do have an option that you can spin it up from in the Microsoft Azure. It's already in the marketplace, but there is there's another tool we call a vOrchestrator, which basically automatically spins up. That workflow is only there in AWS today. It's coming like in a couple of months for Azure as well, but you can actually spin up in the Azure manually, but it won't be part of the automated workflow.
Sorry, no, I meant for a hosted controller deployment.
Yes.
Where you guys host it.
Yes, exactly. Yeah. So we can host it both, but it's not part of the automated workflow yet, in the sense like you have to manually go into the Azure, and we have to go manually into the Azure and spin up the controllers for them. But from a customer perspective, if we are hosting it, typically we tell them that which cloud infrastructure we are hosting it, but they don't have to worry about it because we are providing the SLA times and everything. Yeah. Is there a specific reason that your customer would?
They're a retail customer, so anything Amazon is.
Gotcha. Gotcha. So in that sense, like I think from a roadmap perspective, this will be part of our automated workflow as well. Even today, you would be able to do it. That's not a problem. Cool. From a controller connection and connectivity perspective, I'm actually showing you a recommended way of doing it. Like within the controller deployments, they can be on a public or a private IP address. Only the VBON needs to be on a public IP address. But this is more like a recommended way because of the time that I'm going to cover. So in this case, what they need is IP reachability to each other. So as soon as they have IP reachability, the first thing that happens is in every config that we have, everybody has the address of the VBON. So VBON becomes the glue or the orchestrator in this whole fabric. So whenever any of the controller comes up, they know which VBON that they need to go to. It's usually an FQDN because we have multiple VBONs for redundancy and for scale reasons. So it will be an FQDN that maps to multiple IP addresses. So as soon as the vSmarts comes up or the vManage comes up, they'll go talk to the VBON that we are up. They go through a secure authentication through the cert exchange and make sure that the org name are same. Once they are validated, they establish a secure control plane connection using DTLS or TLS. From a VH perspective, once the control plane connection is up and running, your controllers are up and running, the same workflow happens for the VH as well. In the VH config, there will be a VBON. It will go and ask the VBON that I'm here. This is my serial number. This is the cert I have. Can you authenticate me? So once the VBON authenticates, the VBON sends the information about the vSmart and the vManage. Once it has it, it basically securely established the connection with the other two controllers. After, again, I repeat that after the connection with the vManage and the vSmart is up and running, the connection with the VBON tears down, so there is not a persistent connection with the VBON. It only talks to the VBON when it loses connectivity. So when it loses any of the connectivity with the vSmart or the vManage, it will go and talk to the VBON that what's the update, I lost connectivity. Now from a on-prem controller deployment, so let's suppose the same model with the public IP address, customer want to map it in an on-prem deployment model. So typically they'll be hosting the controllers in a DMZ environment. So they have to host it in a DMZ having the public IP address. Those DMZ will actually make those public IP addresses available onto the internet. There's another option if they want to establish the control plane connectivity through the MPLS cloud as well. Then through their router or the DC core router, they will need to advertise the subnets into the MPLS cloud as well. In our solution, if you got connectivity across multiple transport, it's not necessary that from across all transport you need to establish control plane connectivity. We need at least one transport in order to talk to the controllers. It's a perfectly supported scenario that MPLS could be completely private, do not have access to any of the controllers. But as long as one of the circuit or one of the connection has connectivity to the controller to share the information, that's all we need. But in some cases, for redundancy reason, customer would like to do it because they can actually advertise some public subnets into their MPLS cloud as well. So if that's the case, we can actually establish connectivity across all, or if they happen to just provide us the connectivity with single circuit, that is a supportable model as well. Now, after the connectivity is up and running, the controller establishes the secure control plane connection between each other, and once the VH comes up, it can actually talk through both internet and through MPLS. So from the vManage perspective, we only establish connectivity across only a single transport. We just hash it, and we pick one transport. The reason being there's a lot of stats that gets pushed to the vManage, and we do not want the multiple sessions or instances to actually kill the vManage in terms of how much unnecessary stats we are pushing to the vManage. From the vSmart, we will establish a connection across all the transports. This is a couple of handy links that we posted on this slide deck. The reason being is after this SEVT, you guys must be working with your customers. These are the two top questions that comes up. What ports I need to open? If they are front-ending our stuff through the DMZ, and they have a firewall that they want to go through. These links gives you all the list of the firewall ports that you need to open in order to establish connectivity into the controllers. And at the same time, the other link is the server sizing. The server sizing depends on the number of sites, the number of tunnels that you are building, and how beefy the VM that you guys would need. So those are the two top questions, like whenever we are doing on-prem deployment or even a POC that we are doing, that they would ask about the firewall ports that they need to open and how big the VM instances needs to be. And those information are all available on docs.viptela.com that can be easily accessed. Now, from a scenario perspective, if you walk through the deployment stuff, we talked about the different types of controllers. We talk about the connectivity, how the established connectivity, how the cert exchange happens, how the data plane comes up, the vEdge router. Now, in the next section, I'm going to go deep into what makes up the Viptela config. Like from a config template perspective, if you want to create or pre-built a template before the site comes up, so that the config can be inherited and vManage can push the config. So from a config perspective, there are 4 major things that you need to configure. First of all, on the top, it has the system construct. Inside the system config, we got the org name. Org name uniquely identifies a customer deployment and a customer overlay. We will have a system IP address. System IP address is like a loopback address to identify the router. It's a non-routable IP address that you need to give in order to identify this router. We'll have a site ID to individually identify a site. So the 2 routers, if we are doing it in, if you are deploying it in a redundant fashion, can have the same site ID but a different system IP address. All our policies are based on the site ID, what you want to do from going to site A to site B. The hub and spoke topology that I was talking about, we leverage the site ID that make a site list of the remote site, call them remote, and match onto all the routes coming from those site IDs. So those constructs are important to make this policies really, really simple. In addition to all these config, there is like standard AAA config, host name, that will be part of the system config. As the name suggests, it's basically all the system-related information. Then we had the transport side VPN. So we call it we have a dedicated VPN, which we call VPN 0. That VPN is completely dedicated to transport. We do not need multiple VPNs to terminate multiple transport. Everything related to the transport or the WAN side will terminate into VPN 0. So you have 4 connections, 5 transport connections. All of them will terminate into a VPN 0 config, which is the transport side VPN construct. Moving forward, we got the service side. So on the service side is all your LAN side information. So let's suppose in the LAN, you want to have multiple segments, multiple VPNs or VRF. You can all those needs to be defined in the service section. You can pick any VPN other than the VPN 0 or VPN 512. I already covered the VPN 0. VPN 512 is dedicated to out-of-band management. So you can use any VPNs. The tested software tested number is 64 VPN per site. So, and none of our customers actually needed more than 64, so that has been a tested number for a long time now. So you can have as many as 64 VPNs on a per site basis. And then after the server-side VPN, you got the local policies. So I stressed upon a lot on the centralized policy, on how we can do through the centralized policy. There's another option to do some local ACLs as well. The other places where we can use the local policies, let's suppose you are running some routing protocol on the LAN side. You want to have some route policies locally implemented on the LAN side. So those are the policies that can be leveraged or implemented using the local policies. From an attribute perspective, when you develop a template, there are 3 settings that you will see in the template. There's a default value. Pretty much all of us are familiar with that. In the router config, there are some values that are default values. There's the global value. Like let's suppose if I want to use or I want to define an SNMP or a syslog config in my config template. Chances are in your deployment, all of the SNMP and the syslog are the same. So you can actually give a global value to the SNMP template that here is the server I need to forward my SNMP and syslog across my deployment. The last one is the device specific or the variable. So now we have the option to implement multiple sites and using the same template. So this example, the variable example would be like, let's suppose if a customer has a site that matches where all the transports are internet and MPLS. Now chances are for internet they might be getting an IP address through DSCP. Inside the interface you can have DSCP as a global setting, but for MPLS they would have a specific IP address on a per site level. Every site will have its own IP addresses. So in that case, you can actually use a variable for MPLS cloud that all my connections terminating to this interface, there's the variable value that I need to upload to the vManage. And those variable value will be applied as that particular site comes up, and it will be inherited from the spreadsheet. Any questions up till now? Cool. So one last piece is, in case if you, by mistake, push a wrong config template, there's a self-recovery concept within the config. There's an upgrade confirm timer that you can set. So after 5 minutes, 10 minutes, the default value is 5 minutes. It will actually revert back to the last good known config. So even if you fat finger something and you push something wrong, if the device is not able to establish control plane connectivity, it will revert back to the last good known config. Now, after we configure the config template, the next part we're going to invest some time on is how the policy deployment or the centralized policy works with the Viptela solution. So in this example, what I'm showing is we got the SD-WAN connection on the top. I got the service-side VPNs, VPN 1 and VPN 2 as an example. vEdge is actually part of a site ID, and it has communication to the vSmart through the control plane connection that it has already established. I don't know if you guys are already coming from an architecture section, but this OMP, Overlay Management Protocol, is our proprietary protocol that runs inside the DTLS and the TLS connection that we build with the vSmart. So all the updates that we send in terms of the routes, in terms of the TLOCs, or actually the TLOC is the WAN interfaces. So we call it TLOC in our solution. So that is actually updated or advertised through the OMP protocol. It's just similar to BGP update message with our own extensions to it. So to start with, you can actually enforce a centralized data policy onto this vEdge. The centralized data policy is more like a centralized PBR. Let's suppose if you have the routing table updated, the routing information into the vEdge, but you want to basically influence some kind of a PBR type scenario centrally, like for instance, this application always needs to go to this site, something like that that can be implemented centrally. For that, you would use a data policy. You can also leverage data policy for defining your QoS. Like you want to match particular type of application based on DSCP value, put it in a particular queue. You can actually now do it centrally. You do not have to go locally into each individual devices, configure those ACLs, and implement those. The way we implement it is we have to match onto the site ID. Like if you want to have a particular behavior, we have to apply it to particular site IDs. We have to apply it to particular VPN. So it can be as granular as a per VPN basis. So like whatever service VPNs you got, you can actually apply, but decide or tell which VPN you want to apply that policy. And from a direction perspective, what you see here is from service or from tunnel. What that means is where you want to apply that policy, when the traffic is getting into the box from the LAN side, or when it's coming from the tunnel or from the overlay that you want to apply this behavior. So you can also define the directions for the data policies as well. Now, data policy is great when you have a blackout situation. As long as you have a route, As long as you have the option, it can do the PBRs and everything. It's great, like as long as it's a simple blackout situation. But let's suppose if the link is not performing at an optimal level. It's a brownout situation. You are seeing loss, latency, and jitter. And you want to enforce SD-WAN to basically tell which route to take based on those link conditions. For that, we actually leverage the application-aware routing policy. What it does is, from the hierarchy perspective, you will have the SLA. You define the SLA, let's suppose for an application, for a voice application, let's suppose you say that I do not want to take a circuit that is more than 4% of loss and giving me 160 millisecond of latency. I want to keep this traffic to a circuit that is below that. Those are the policies that you will be defining under the app-aware policy. So this will basically take care of any of your link condition or brownout situation and can actually react to those brownout situations. And then lastly is the control policy. Control policy is again same as the routing updates. Now instead of processing those routing updates locally on the vEdge router, you are asking vSmart to actually process those routing updates. So the hub and spoke example that I gave was more like a control policy, like all the routes and all the information getting advertised to the vSmart controller, what vSmart actually should do before it advertises to the other vEdges or to the other routers in the environment. So the control policy is more like what to do with the routing updates. So again, just to summarize this slide, we got 3 types of policies that we talked about. We have the data policy, which is more like a centralized PBR. We got the app-aware policy, which actually takes care of the brownout situation. If the link conditions are bad, it can help automatically reroute the traffic, and then, or fail over the traffic. And then we have the control policies, which is basically telling the vSmart what to do with the routing update that you're receiving from a vEdge, which sites that you need to advertise and which to not to. And then from an implementation perspective, everything actually, so initially at the start of the slide, I made a comment that everything from a day-to-day operation perspective is being done through the vManage. So all the policy that we actually define is actually on the vManage. The vManage will actually push it to the vSmart. So from your perspective or from your customer perspective, the customer do not have to go into the vSmart and configure those. You'll be doing it through the vManage, which in one of the labs we'll be doing it here as well, and it will get pushed to the vSmart, and then the vSmart will take the actions. Now, the next piece is the cloud on-ramp. So again, the way we market our solution is we provide the next-gen SD-WAN solution. So with that, we want to make sure that we are fully committed to customers' cloud adoption. So the 2 types of trends, and probably in your customer space, you guys must be seeing the same thing, is customer adapting cloud infrastructure as a service or software as a service. In terms of infrastructure as a service, 3 famous provider would be like AWS being the most popular, Azure is catching up, Google platform is investing heavily. So those are the 3 cloud providers that we are initially looking to support. Actually, for AWS, we already have a workflow. We already have the support that I'm going to walk through. Azure workflow is coming in the next release, and there's works going on with Google platform because there are some stuff that that the Google platform itself was lacking. So we are consistently working with Google to actually have our image on the marketplace, on their marketplace as well. The use case that this cloud on-ramp IaaS solve is, let's suppose the customer has different VPCs. They are hosting different VPCs in their AWS environment. One option could be that we simply actually front-end their VPCs with an individual vEdge router, but that way they'll have they can have hundreds or thousands of VPCs, and they'll be front-ending multiple of the routers and the multiple of sites. What we provide them with the option is they can actually create a transit VPC where they can terminate all their individual VPCs from the Azure perspective, into our transit VPC, and we take all the routes, learn about all those routes, and then now this AWS region or this AWS site is no different than an actual site or a data center. Even though it's in the public cloud infrastructure, we are front-ending. This will become the service side for us. We advertise on the overlay all the route updates that we are receiving from the AWS, and this will be just like a static or a standard data center deployment that they have it or they are used to today. We not only just provide this support like architecturally, it's actually automated in the workflow as well. So in the vManage, it's a point and click that actually configures everything for the customer. What we need from the customer is access into their AWS instance, like the login information so that we can access the AWS APIs, but all this spin up is actually automatically generated. So what we define is what are the login information to actually access the cloud infrastructure. We will spin up the pair of vEdges. We will establish the IPsec connectivity back to their individual VPCs on their VGWs. And then on top of it, we will run the BGP in order to learn the routes from all the VPCs. So all this workflow from a customer perspective is all automated. Like it will basically provision their end-to-end infrastructure within a matter of 10 minutes, and they'll have this whole AWS environment part of their WAN infrastructure, which if you look at it is a quite cumbersome, like if they have to individually create those front-end gateway routers, individually bringing them into their network. And on the transit VPC side, they can actually use internet, which we use by default. They can terminate their direct connect options as well, so that we have multiple transport getting into their environment. So that provides a seamless integration into their SD-WAN infrastructure through this automated workflow. So the IaaS was one piece of the solution. Now the other piece is the SaaS-based services. So in infrastructure as a service use case, we can actually deploy our vEdge router. We can extend or stretch our overlay into the IaaS services. But with SaaS-based service, we do not have such infrastructure. It's just a cloud application on the internet that we are trying to access. So the way we do it is, let's suppose if we have, or a customer has multiple access through their DIA failover case. So across the multiple service provider, we will provide that access to the cloud application. And not only that, but we also monitor the performance of the SaaS application across all the exit points that are local. We will basically check the health of the application through HTTP pings. And then based on that, we will identify what's the best circuit to take in order to exit out. So now, even though we do not have visibility end-to-end, we still know how this solution or the application is performing from point A getting into the cloud. Similarly, another use case could be that they can have one connectivity into the cloud provider through their internet breakout. The other connectivity into the cloud provider can be through the MPLS circuit through the data center. So in that case also, we will monitor the performance through the ISP, plus also through the MPLS provider going into the data center. So all the stats that we are collecting on what it takes in order to get from a remote site to the data center, and from data center to the cloud application, we will have the visibility into end-to-end path. So if the direct internet access does not give us the optimal application performance, we can actually take the MPLS route through the data center if it's configured that way. Go ahead. We are actually looking at the HTTP ping, the probing, and whatever the new session comes in, it basically takes that. Now, from a segmentation and security perspective, there are different ways. Basically, let me just open up the different use cases. So this slide basically covers what we are doing from a security perspective for intra-VPN, for inter-VPN, or if we are accessing the cloud. So let's just start with the intra-VPN use case. The way we can actually have the traffic define, or the traffic flow define that within the same VPN, if a customer wants to insert a third-party firewall into the mix, into the data path, that can be achieved through our service insertion policies. So we can do a service insertion where we know from where the service is getting advertised. We can punt the traffic to that service location, get it inspected, and gets onto the other side of the VPN. We can do data policy, like the centralized policy that I was talking about. We can implement it in an ACL fashion that block this kind of a traffic going from X to Y. Or we can also have support for zone-based firewalling, which is coming end of this month, where through the VPN we can do flow-based monitoring across the same VPN, that from this IP to this IP we want to do a zone-based firewalling. For inter-VPN, we can actually monitor the traffic going across different VPN. So even though the default behavior is that the two VPNs cannot talk to each other, but through our policies, we can do extranet use case and do route leaking between the VPN. This comes, some of the use cases that we can think about is some data center hosting some services that is being used by other VPNs as well. So you need to leak those routes into the server-side VPN. So we can actually do extranet or the route leaking. And you want to do a firewall in between when the traffic goes from VPN 1 to VPN 2, you can do it. You can also implement it, again, the same way through the data policies or the ACL. Or with the zone-based firewall, you can actually create separate zones for VPN 1 and VPN 2 and do it more at a zone level. Like from zone 1 to zone 2, this is the policy that I want to do if it's going across different VPNs. And then the third use case is the cloud VPN. If a customer is trying to access the cloud from VPN 1, there can be a direct internet access where we can have a firewall in the between so that it can inspect the traffic, or it can basically go to a cloud firewall, get it inspected. We can integrate Umbrella or any third-party firewall services in the cloud, or we can do it with the zone-based firewall as well. To be perfectly honest, the intra-VPN and the cloud would be the two prevalent cases that you will see in your deployments. The inter-VPN is not so common because, like, if they're doing segmentation, they want to still keep the traffic secure across different VPNs. Now, from high availability and scale perspective, so if you look at the solution, everything from a controller infrastructure perspective is horizontally scalable. We can, and then at the same time on a per device level, there are some limitations because how beefy the processor is on how much it can handle. So from a VBON perspective, each VBON can take up to 1,500 simultaneous connections. If you have 3, it can go to 4,500. And then we have tested with the 6 VBON in our environment. But again, it's just the testing numbers. It's just like everything is horizontally scalable, and you can add it more and more. From a vSmart perspective, each vSmart will take care of up to 54 connections per vSmart. So if you got 3, you can do 5,400 into 3. And again, horizontal design works in that manner too, that you can add more in order to terminate more connections. From a vManage perspective, we got 2,000 devices or 2,000 sessions per vManage. Again, with 3, if you are doing cluster deployment, it can go up to 6,000. Again, the tested number is with 6 vManages, and then it can go beyond if there's a requirement for us to go even more than that. The way it works is the VBON is behind a FQDN. So whenever we spin up the VBON, we actually update the public DNS with the FQDN entry, what VBON entry or the FQDN we need to use, and behind that we can have all the individual VBONs there. From a connection perspective, the vEdge will actually go to that FQDN. It will pick one of the servers from the VBON. Once the authentication is done, it establishes the connection with the vSmarts and the vManage, and the way it picks it, it's basically hashed to one of them. So it will basically hash the connections. into the vSmart. Now, from a tunnel perspective, so those, go ahead. You do have to do it, and that's where, remember that scaling guide, the initially VM sizing, and the firewall ports that I mentioned. So those are the questions that would come up. So for instance, if your customer is doing 100-site deployment, and if you look at the numbers, until you go more than 1,000 sites, you do not even have to worry about it. Yeah, so exactly. So I think what we will need to know, and once we have this portal ready to go and all that, what you need to do is you need to provide the number of sites that the customer has. We will take the initial requirement, whoever from the Viptela side that you will be working on. The answer is yes, we need to take care of it. We cannot just go blind without prep work that, okay, whatever is it, we just start with basic and just start to expand. It's better to prepare, and those scaling numbers would be handy, how big the deployment will be. Now, those were the scale numbers from a controller perspective. Now, the other element is a tunnel scale. How much tunnel, how many tunnels that each devices or each router can support. So those tunnel number will be important for you as well in order to decide what platform to pick. If it's a data center, if it's a remote site, it's not just only the bandwidth. It's on also the tunnel scale. So if it's a data center will be consolidating all the data tunnels into the data center router. So you want to make sure you pick a platform that can actually support that kind of a tunnel scale. From a tunnel scale number, our lowest end box, the low end box, which is the VH100, does up to 250 tunnels. And then the VH1000, which is the 1 gig version, it does the 1500 tunnels, and the VH2K can do up to 6,000 tunnels. So if it's a data center with, let's suppose, 16, 12, or 18,000 tunnels, those can be horizontally scaled as well. So in our deployment, where we have one of the customers doing 6,500 sites, and then if they have two tunnels per site, that would, like, the data center scale would go up to 13,000. So those can be horizontally scaled as well from a data center perspective. You can have, instead of 2, the 4 or the 6 or the 8. So those can be horizontally scalable as well in order to meet the tunnel scale. From a route perspective, we can do 16 equal cost path. So 16 equal cost multipath routes from a VH perspective that we can actually support. Beyond that, we will just pick the like randomly top 16 that we are selecting to the vSmart. So only from a routing perspective, we can do 16 equal cost multipaths for a given route. Now, from the high availability perspective, there are 3 options that are listed on the right-hand side. If a customer is deploying a data center, you will probably get a use case of the top one where a customer has multiple internet and multiple MPLS connection. So from a redundancy perspective, you can terminate each on each router. That way you can have redundancy, plus the circuits are all available on all the VH router as well. But this is not the case for everywhere. Like, a customer can also have a remote site where it has only one MPLS, one internet, but at the same time it wants to have a transport redundancy on both the platforms that it's deploying. So there is another deployment option which we call using T-lock extension. So what we can do is we can terminate one type of a transport on one box, like internet on one, MPLS on the other, and we can have an interlink to extend one transport over the other. So now, even though you are terminating only one, through the interlink, it can actually leverage and monitor the MPLS circuit as well, and can always pick the best circuit. So now you're providing redundancy through this T-lock extended link, and also at the same time you are providing active-active type of a behavior across all the transport without customer needing an extra circuit. And the last one is everything is terminated onto a switch. So all the circuits and the transport terminates to a switch, and then we actually connect to the switch, which again is pretty similar to the top case that we have listed here. The next section is the migration scenarios, how to actually go about the migration if a customer is already have a traditional WAN deployed and now they want to go about the migration. So from a sequence of steps, again we talked about and we went through the same sequence as well. You need to have the controllers up and running. So before anything happens, the controller needs to be up and running. Either they can be on-prem or they could be with the Cisco cloud. Again, that's the recommended way of doing it. Once the controllers are up and running, you should be deploying the data center. Data center should be your first site that you want to deploy. And then as part of this next few slides, we're going to talk about how what would be the recommended way of doing it in terms of the data center migration. So once the data center is migrated, the way we can design it, your existing routing can continue to work as is, and we sit on the side ready to actually accept any SD-WAN traffic. Once the data center is migrated, we start off with the branches one by one. And once all the migration is done through the branch, we can basically cut over the existing circuits to the existing router in the data center. And those are the details we're going to go into the next few slides. So this is the sequence we should follow: controllers, data center, and last, the branches. Now, from a branch deployment perspective, here I got the SD-WAN router that is already deployed in the data center. I got two circuits coming in. I got the internet circuit, the MPLS circuit, and then I got the non-SD-WAN side, which is a non-migrated side. From a branch perspective, I brought up a branch. I got the VPN 0 configured, and I got the service side VPN 1 configured. Based on that routing, I'm receiving the SD-WAN routes from the data center, like all the SD-WAN routes that the data center's local route basically through the OMP. And then I'm also receiving the non-SD-WAN routes because all the MPLS connections routes for the non-migrated side will be getting learned on the data center. So from the data center, I'll be learning all my SD-WAN and non-SD-WAN routes. So in the interim, we want the communication. The preferred way is to go for the migrated to the non-migrated side is to go through the data center. Data center should have all the non-migrated routes into the underlay, and we should route through the data center. From a local branch perspective, the local prefixes, the OMP prefixes, will be advertised up to the data center. And then from a routing perspective, anything which is SD-WAN, we go to the data center directly, and anything to the underlay or the non-SD-WAN side, it will be going through the data center to the non-SD-WAN sites. Now, since data center is key to this whole deployment, I'm going to cover or maybe double click into how we want to configure or set up the data center environment. So from a data center perspective, you got the same concepts. You got the VPN 0, you got the VPN 1. And what we will do is, instead of directly terminating the circuit into the SD-WAN router, we're going to actually connect to the existing CE router in the data center. So we just take a connection of the existing CE router to actually establish tunnels over VPN 0. So our overlay tunnels are up in order to route the traffic. Plus, at the same time, this core switches, which is their existing connectivity, is already connecting to their existing CEs. So through the core switches, I'm actually learning about the non-migrated subnets. So all the non-migrated subnets will actually get advertised through the CE router down to the core, and through the core, I'll be learning it and advertising into the OMP. So in this case, the walkthrough would be we will be learning about the SD-WAN prefixes through OMP from the remote side. I'm going to redistribute my OMP subnets into my local BGP or OSPF, whatever protocol that I'm learning. Once I do that, this core will have all the SD-WAN prefixes learned through whatever routing protocol I'm running on the core. I will receive the non-SD-WAN prefixes from the CE router down to the core. So core becomes the aggregated owner of the subnets for non-SD-WAN and SD-WAN subnets. And then the core will advertise the SD-WAN prefixes to this CE router. So from the underlay perspective, all the SD-WAN migrated subnets will be learned through the data center through the CE router. And then from a routing perspective, if I want to talk to the migrated side, I'm going to simply hit the core, hit the Cisco SD-WAN router, hit the remote side, and get it on the other side. If I want to talk to the non-migrated side, simply through the core, I have a direct connection to the CE, and I can go to the legacy side. Similarly, if somebody wants to initiate a traffic from the remote side, those routes are getting run through the SD-WAN from the data center, and all the traffic will be attracted to the data center. Now, another use case that I want to quickly cover is the data center priority. So for instance, if a customer has multiple data centers, they want to prefer one data center over the other. This can also be achieved through the policies. The example could be if a customer has an East Coast data center or a West Coast data center, and then it wants all the East Coast sites to be preferring the East Coast data center, and the West Coast sites to be preferring the West Coast data center, and then if one goes away, the traffic should be able to fail over onto the other data center. So what we can do through our policies, we can define and make it a more based on the site list. We can tell that for this site list, which could be the East Coast remote site, this is the data center, or this is the TLOC that I want to prefer, which will be owned by the data center vEdges, and then the other one becomes the backup. For the other sites, I do the vice versa. I'll prefer the other data center and have the other one being the backup. Now, another scenario is, let's suppose if there are any services that you guys are hosting, which could be the WAS or UC type services. If you want to integrate that, what we'll need to do is we need to attract the traffic to VPN1, and we need to have a way to do a PBR type scenario where we push all that type of traffic to the WAS. So what we need to do in this scenario is, on the ingress side, the local policy that we talked about is we can match onto the type of the traffic. We can have the next hop being the WAS router or the UC appliance, and the traffic will actually go to this, get its service, the traffic comes back onto the SD-WAN and gets forwarded. For the traffic coming back, we can actually have a policy from tunnel onto the VPN 0, that once you receive the traffic onto the tunnel, direct it back again to the WAS or the UC, and then get its service and comes back here. So basically, you would need, it will basically mimic a WCCP type behavior, where we will have the ingress ACL through the PBR directed all the traffic that is originating, and from if the traffic is coming back, we will do it from the tunnel. So next we're gonna go into the hands-on lab. Before that, any questions or any specific scenarios that you guys wanted to discuss and did not see it on the slide? So that's cool. So let me. Okay. Okay. So the next section we're gonna do is the hands-on lab. There are a couple of labs that we have set it up for you, time permitting. We can do the third one as well, but if not, then we can actually forward you the recording for the third lab. So the way the labs are, we're going to do the control policy on the hub and spoke topology. Like we will walk through the workflow, how we can come up with the hub and spoke topology through this hands-on lab. The next one was the app-aware policy, where we can define the SLAs and show how it basically influenced the routing and what are the different elements of it. The third one that I had it was the feature template, how to build up the config template. But let's suppose how much time we have, and we'll go it by then. And then from a pod perspective, you guys can actually go to, actually before we go into it, can we guys set you up in groups of 2? How many people we got? 1, 2, 3, 4. Yeah, we got like 10 pods, so if you can have groups of 2 and you guys can share the pod, you guys can come together, you guys can do it together. Yeah, that's good. Probably you might have to move on that side.
You have to assign pod numbers though.
Yeah, that I'll walk through like once we have the. Cool. So basically what you need to do is you have to go to this link. You guys can actually take 1. You can take 2. You guys can take 3. Probably have to. So 1, 2, 3. You guys? Huh? Yeah, you guys can take 1. Yeah. 1, 2, 3, 4, 5, 6. Yeah, you can take 6. And you can actually take 7. You can, but I think the problem is you won't be able to do the policy stuff together, because otherwise you will step on each other's toes. Yeah, I'm actually walked through the lab stuff. So once you guys have access to it, are you guys able to access the lab?
Which pod number should we use?
Okay, so okay. 1, 2, 3. Okay, then you can do 1, 2, 3, 4, 5. You can take 5. You can take 7, and you guys got 6, right? 6. Yeah. So everybody is on the login page? Sure.
Bug on your slide. It's actually 1 digit except for 10. Pod 1 is pod
0, 1?
It's not 0, 1.
It's 1, right? Yeah.
Text is kind of misleading, the 2 digit.
Oh, okay, got it. Everybody has access? Cool. Good to go. What's that? Yeah. Share it again, basically. Okay, cool. Cool. So based on your pod numbers, and then you guys can click the sandboxes, and then here I can do return to sandbox. You guys should all see a topology. Are you good? Cool. So next thing you will access is the vManage. Are we all on the login page? Cool. So the password is admin. Are you all in the lab, in the vManage? Cool. The next thing we can actually take a look at it is go to network. Launch a branch VH2. Go to real time. What's that? Real time? Yeah, real time. Pick a branch, any branch router, branch VH2. Are we good? So, and then under the device option, just take a look at it. BFD. You look at the bunch of BFD sessions, which is nothing but the IPsec connection, the data plane connection. So what I'm trying to show here is right now, since by default it's a full mesh type of a topology, you see tunnels to all the other sites. So 100 and 200 is our data center, but I'm actually building my tunnels to all those other sites as well, like 30, 40, and so it's a full mesh type of a network. So now we want to do a policy where it will actually turn it into a hub and spoke type of a network. Make sense? Everything? Cool. So now,
is a BFD session defined by the VPN, whether it be a service or?
no. So basically, what BFD session is basically the IPsec connection from site A to site B. It's the overlay connection, which will actually carry all the service side VPNs inside that. So this is just like a transport going from site A to site B. In that, I can carry multiple, like all the different VPNs. Yeah, that's VPN 0, exactly. Now, after we validated that this is the current state of the network, now I want to do a policy. So basically go to configuration, policies. I can do add a policy. So once you do add a policy, now I'm in a GUI construct in order to just like start setting it up. The way it works, just from a high level perspective, you need to define the site list or different types of lists basically. Different types of list identifies what you are trying to match, where you want to apply it. So those lists will be required. Like for instance, if I want to do hub and spoke between remote sites and the data center site, I need to define 2 site lists, one for the remote site and one for the data center sites. So now I will pick the site list from my left pane, and then I'll define my new site list and I'll make it a name SEVT DC sites. And then DC sites are 100 and 200 that we have it in the topology. Are you good here? So now the next site list I want to do is SEVT remote sites. And then the site numbers are 10, 20, and 30. Cool. And the VPN that I have it is VPN 1. So I'll do a VPN list policy. I'm using VPN 1. So we got 3 lists, one for the site, 2 for the site list, and 1 for the VPN. Next, I do a next. Now, under my add topology, I can define different types of policies. So here, I can select under add topology a hub and spoke topology. Make sense? Then I have the add hub and spoke, and I got the option to set up my hubs and set up my spoke sites. So I click add hub. Out of the site list that I've defined, I'll pick my hub site and add it here. Similarly, for the spoke, I'll click and pick my remote site. Make sense? Now this hub and spoke policies is actually created. I can do next. We can do the other app aware policies and all that in the later workflow, in the next lab. I can name this policy Now, once I created the policy, it says here false. I can actually click and activate it. So we're taking time to apply it to all the vSmarts. So it basically vManage is pushing the policies to the vSmarts. Yeah. No, so you can actually do it with 2 as well. This was just the example. The good thing is, again, you can actually add it or subtract it seamlessly because everything from an orchestration perspective is on vBond, right? So now even if I add a 4th one or a 5th one, it will just talk to the vBond and get itself registered and all that. But like 2 is good enough. Like in a typical deployment where you do not have the scale, we do at least 2 and not more than that. Go ahead. Sure, I'm going to show you after it gets applied. I can show you that as well. You want to see the CLI? Yes, absolutely. It's there is no drawback. It's just that you need to be up to speed on how the policy works and everything, all the framework. But if you know the framework, yeah, there is no disadvantage. From a power perspective, I think you can do much more than, because this workflow can only guide you with the use cases that is in there. With the policy, with the CLI policy, you can do whatever. Because we can match on any attribute and set any attribute, right? So there's a particular way we are doing it through the workflow. But if there is any flexible architecture that you want to do that the workflow is not able to do it, you can actually have more power with CLI. But from an ease of use perspective, because like if you look at it, if 80 to 90% of the customer actually fell into this use cases where we come up with the workflow, GUI workflow, for them it's the point and click makes more sense. But with, yeah. Yeah. Yes. 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 So basically the reason why we created VPN 1, from a topology perspective, right? From a topology perspective, it's your server-side VPN that you want to create hub and spoke or a spoke-to-spoke. The VPN 0 is basically just the transport that you are trying to create. So basically, let's suppose the routes are actually stored, like if you are advertising a route from site A to site B, those are actually VPN 1 routes, the overlay routes, right? Those are not on VPN 0. And between those routes, between the VPN 1 routes, you want to act like a hub and spoke kind of a topology, that the VPN 1 routes can only access the data center, cannot access anything else. Yes. The reason why we have the transport VPN, because that's where we are actually building our tunnels. So basically transport VPN, if you look at it MPLS world, right? MPLS provides you the plane, the data plane on which the inside VPNs ride on, right? It's the same concept. The transport VPN creates that control plane in order for the other VPNs to get into, like we encapsulate into VPN 0, and all the other VPNs, the server-side VPN is inside that VPN. Yeah. Exactly. It's exactly an overlay. The VPN 0 is exactly an overlay, which is adding its own encapsulation so that the service provider do not even know about your routes. It gets opened up on the other vEdge. Now, if I want to view it, basically this is the control policy I created. In the back end, it's just the CLI that we are doing, right? So basically what I'm doing is sequence 10, match route, site list from this data center side, coming from this VPN list that we created, action accept. So we are accepting all the routes from the data center sites coming from that VPN and doing an action accept. The next one is the, so basically the VH router from a route perspective advertise two things, the route and the TLOC. The TLOC is used in order to build the IPsec tunnels. So we not only just want to accept the routes, we want to accept the TLOCs as well. So what we do also is site list coming from the DC side, accept the TLOCs as well, like the WAN connection, so that we create that hub and spoke. And everything else is reject. So all the remote site that we are receiving from other remote sites are getting rejected. And when we apply it on the remote site in the bottom. So basically, in essence, what we are saying is only send the tunnel information and the routes from the data centers to the remote site and nothing else. And in the end, we create a hub and spoke type of a topology. What's that?
We just see VPN 1, just the list VPN 1, and that's it.
So go back.
Around the policies, I just tweak that.
So when we are selecting options, you probably have not selected those match criteria. Maybe after the session, I can take a look at your policy. Yeah, it's basically what we did was initially we match onto the routes from the data center, from the remote side. That step might have got missed here, so I'll take a look at it after the session. So now, going back from where we started, now if I go back and take a look at my branch VH3, now I am only building tunnels to my 100 and 200, which is my data centers. Before, I was making tunnels to all the 20, 30s, and all the other sites, all the remote sites. After I implemented this policy, all I'm building the tunnels is to my data center. And just through walking through the workflow, you basically change your entire network into a hub and spoke topology. Cool. Are we good with this lab? So now we can quickly do the other lab, which is the application aware lab. So under the option, I can actually select the traffic policy. Actually, before that, let's just go to the list again. So all the matching criteria, like all the sites and all the VPNs, we actually match it to the list. The SLAs are also defined under the list criteria. So now I can define my new application list name, which can be SEVT underscore SLA. I have loss of less 4%. Latency, I can put 180. Jitter, I can keep it blank too. So I created my new SLA that this is the SLA I want to one of my application to follow. Now, in my policy, I can go to custom options, create traffic policy, and under application aware policy, I can create a new one. And I can name it SEVT AAR. Are we good? You can keep it blank as well. So I'm just using loss and latency at this point. Okay, so let me just go back. So after I define my list, under my custom option, I select traffic policy. Here are we, right? Now under the custom option, we define the SLA first under the list. What are you guys seeing in your screen? Do you got the SLA created? Okay, so let me just delete that and just do it. Okay, right? So we are on the list page, right? Go to custom options, list. We are on this page. Okay, so then.
Yeah, there's no custom options.
Oh, really? Are you guys trying to edit your existing policy or creating a new one? Let's just go through the workflow, and then I can take a look at your vManage after the session. Let's just go through the workflow and take a look at all the different steps that is needed. So basically what I did was under the, we have to create the list. So under the list, I went into my SLA class. I defined my SLA class. I name it to SEVT underscore SLA. I define my loss, like how much loss I want to kept it for that application. Let's suppose I keep it 6. I kept the latency 150, and then I added and create an SLA here. And then under the traffic policy, I can create a policy and I can add a sequence, what kind of traffic I want to match and what I wanted to do with it. So let's suppose in my application aware policy, I'm actually matching application. In this case, for this example, I'm matching my DSCP. I'm keeping my DSCP as 34, some application that I want to keep it. I do the save match conditions, and then the next action what I want to take. So there is options where I can actually define the SLA. So in this, I will define my SLA class that, okay, for this application, any traffic with DHCP value 34, I want to make sure that it follows the SEVT SLA, which we define as like when we are creating the list. And then, if that criteria is met, what should I do with that type of a traffic? I can have preferred colors. So if I keep the preferred color, so then for all that traffic that is meeting the SLA, I will actually keep the preferred circuit as the primary one. Or if I don't select any preferred circuit, it will load balance across all the circuit that will meet the SLA. I can make it a preferred strict that only keep that circuit. If that doesn't meet the SLA, drop the traffic. So in this case, let me see what color I have it here. So I can keep my preferred color, one of the ones that I'm using here, which is gold. So what I'm saying here is if you meet the SLA, always keep it on the gold circuit. And then I can do save web. So now I saved it. Now I've created an individual app aware policy, and now here I can add this policy here to the same policy workflow that I did it before. Before I did it for the topology one. This time I can actually do it for my traffic rules one. So I do import existing SCVT AR. And then I'm picking up which site I want to select, and then what's the VPN that I want to select for this policy. Now if I look at this policy through the preview, so what it's saying is, and again, we can take a look at your setup as well, like if you guys are missing that custom options. But what this policy is basically saying is we got the SLA class where we define the SLA, what's the latency and the loss that you want to keep it for your application. What are the type of the traffic that you want to match and apply on? So what I'm saying is the traffic coming from VPN list, this which is my LAN site VPN or LAN site network that I have set it up for the customer. From that LAN, match the traffic with DHCP value of 34. Action, if it meets the SLA class, preferred the gold circuit. And then below, I'm actually defining my list, the site list, and then I'm basically applying the policies. So the policy I'm applying it is both on remote side and the data center side. So what I've done is I've created that policy and I haven't activated it. So what we can do is quickly we can actually take a look at it. Before applying the policy, we can see that it's basically taking both the paths, like the two transport it has, and then after we apply the traffic, how the traffic just switched to a single circuit. So I can go to monitor, network, branch VH3. There's a troubleshooting section where we can, this is also a pretty cool troubleshooting tool where you will be able to simulate flows from one site to another. So I think I got the VPN 1. Gig02 source IP 10.this. So basically what I'm trying to do is creating a flow from source to destination IP address with a DSCP value of 34. So now I see I can take gold and MPLS both when I try to simulate the packet with the DSCP value of 34. Now simply I can go and apply my policy. So again, it's going through all the vSmarts and pushing the policies. So done. Now I can go do the same vEdge, troubleshooting, simulate flows. Now you see after I implemented the policy, now it's always preferring the gold circuit. Before it was basically doing gold and MPLS both load balancing across all. So again, just from a like how powerful this centralized policy could be, that you can actually enforce it across all your network. If some application is not performing well, you want to force it to an MPLS circuit, define some SLAs. This can be centrally controlled and centrally implemented. So last thing is, I don't think we have enough time to complete that the template lab, which I knew from the beginning that we will run short of time. But we will send you the video recording on how to build the feature templates individually, like the different construct or different sections of the config that we talked about, like the system, the transport VPN, the LAN side VPN, the local policies that we are going to cover in those video that we're going to share with you. And then, okay, that's good. That's good then. I thought it was 3:15 then. Then good. Then actually we can actually play around with the templates as well. So again, from a template perspective, we have two options. We can actually create the CLI templates. We can create the feature template. The feature template are more like the GUI-based templates, which again walks through the GUI workflow and then lets you configure the devices. From a CLI perspective, which all of our devices are connected through the CLI template, it's basically pretty simple. You basically create a CLI of the config, you dump it, you create a template out of it. Right now, it's a static configuration that you see in your vManages, but with the curly brackets, you can make any of these values as a variable. Like for instance, I can simply edit this and this host name, which is supposed to change for all of the devices, I can do it with a curly bracket and it becomes the variable. Now every time you apply the template, it actually asks for that value in order to bring up a site. So if I want to create my host name, the MPLS IP address as a variable, I can easily do it. What we want to focus as part of this session is basically the feature template. How we actually can create those feature template. In terms of the hierarchy, there are two parts of it. One is the device template. The device template has the whole configuration which actually inherits the individual feature template. The example is you can have a BGP configuration which is exactly same across your all deployment. You are using a particular neighbor, this is the AS that you want to use, but from a from a config perspective, it's pretty standard. And then you have different types of sites. Like you have one site that has multiple internet, one site has MPLS and internet. So you're creating multiple device templates, but those individual feature templates that you're implementing can be inherited into multiple device templates. It could be an SNMP template that you have created, like the same template used across all the different devices, and the device templates will actually inherit those. Now in this, I'm going to start with let's suppose creating a template from the feature template. The GUI gives me an option to select a device model. What is the device that I want to select? In this case, we are all using VH Cloud. So I select VH Cloud as an option. And then I can name it as SEVT branch VH3. And then I can give a description of SEVT branch 3. Now here, basically the initial slides when we talked about the different sections we have, we got the system information that we talked about, where we have the system related information that goes in the basic information, all the transport related and the management related stuff, which is VPN 0 and VPN 5 and 12, goes into the transport and the VPN 5 and 12 section. And then we have the service VPN, which is all the LAN side VPN information that you can add. And then we got some additional templates for banner, policy, SNMP that you want to add to the device. From a basic device template configuration, we have an option. We can keep a default template, like a default value for the template, or we can create our own template as well. So if I do create my own template, from this template, now I'm creating an individual feature or individual system template that I want to use for my sites. Now I can give the name SEVT system template. Now here, when you look at the slide, we had the option where you can actually set it up as a global value, or you can set it up as a device specific. So if I keep it as a device specific, that value will be taken it as a variable. So every time when I try to attach a template to a device, this is the variable that I'll be in need, I'll need to enter it when I'm bringing up a device. So in this case, I can keep my site ID, as my site ID will change across my deployments as a variable, and the rest of the stuff, system IP and everything else, I can keep it to default values, and I save this template. And then after I'm done with my basic information, I have the AAA templates that I can use the default one. If customer has TACAX integration and all that, they can add their own the specific AAA templates. But the rest of it for this demo, I can keep it as default. Now, inside the transport and management VPN, I can actually create my VPN 0 template. So basically inside the VPN 0 and the transport, there are two things. One, there is the VPN template, like what's the VPN name, what are the routes that I need in that, or what kind of routing protocol that I want to enter. Those are all the information that will go inside this VPN 0 template that you see here. The other one that I can actually add are the individual interfaces. So for instance, if I have multiple connections that are terminating into VPN 0, those are the additional interface that I need to add. So if you look at our topology, so in this case, let me... So let me go back to my other slide. So if you look at it, if I'm creating my branch VH3 template, I got a transport connection that is connecting to the goal. I have a connection that is connecting to the other router. So basically all these transport side connection goes into the VPN 0. So those will be all the interfaces that I'll be needing as part of this template for this device. So what I can do is, since I need 3 interfaces, I'll actually add 3 interfaces from my right pane of the glass. I can set up my individual VPN interfaces by creating a template for the interface. So now I'm actually in the interface template creating those. So I can call it So the other option that I got here is the interface can be in a shut state or a no shut stage. So by default, the default value is a shutdown stage. So if I can actually set it up as a global value that keep it no shut. Global value. Why it's, let me see. Let me see, it's just not letting me change it. Yeah. So basically I change it to my the interface to no shut. I can name my interface. So typically if it's all MPLS, same types of device, we want the same interface to be used by the customer. So we can actually have it as a global value, give it a name. You have the option to set up the IP configuration, whether it's you need to have a static IP or a DHCP based IP address. In our setup, it's static, and then once you need to enter that static IP address, you need to give a device specific value as well. So the device specific will make this as a variable. And the rest of it, we can actually walk through it. If it's on the VPN 0 interface, if it's one of our overlay interface, it needs to be configured as a tunnel interface. So at the bottom, what you see here is the tunnel interface is by default off. But if we are creating an overlay tunnel over it, if it's an MPLS interface and all that, we need to turn it on, and then there's a whole set of options on how you can actually configure the tunnel interface comes in. So I'll set it up as tunnel interface on, and once I do it, you have the options of all the tunnel related information like color. So the color uniquely identifies a provider. So in our logic, we basically tag the service provider link with different colors that uniquely identify whether it's a biz internet connection from AT&T, from Comcast, or it's an MPLS connection from AT&T or Verizon. So basically the color actually helps us to tag a service provider, what type of service provider it is. And I can do global, and once I do the global, I have the whole suite of options for the colors that I can actually set up or use. So in our example, we were using goal. I can keep it the goal. The next option on the right is whether you want to keep it a restrict or a non-restrict. This is again going into deep into how we actually set up tunnels. If you set it up as restrict, it only allows to establish tunnels with the same colors. So for instance, if it's an MPLS private type of a connection, you do not want that connection to be used in establishing tunnels with some other MPLS network because it's completely a private network. If it's a non-restrict, that is the case for the internet connections. Like for instance, if it's the internet from Comcast or AT&T internet, you want that internet circuit to be making tunnels or IPsec tunnels across different colors. So if you set it up restrict, it's mostly for the private MPLS type connections. If you keep it non-restrict, it's mostly for the internet type connectivity. And the rest of the options are just all tunnel related. We covered a bit like whether you want the control connections across from that transport or not. So that is also a configurable option that you see under the control connection. So you can keep it on or off. Like if the MPLS circuit has connectivity through the to the controller through the MPLS network, then you keep the control connections on that tunnel interface. Otherwise, you keep it off. And then the next section is the allow service. So by default, since we will be sitting at the edge, we want to make sure that we block all the connections from the outside network hitting our tunnel interfaces, except for the IPsec or the DTLS connection. So by default, we keep the allow service off. So we basically block all our connections into the tunnel interface so that it will be secure at the edge. But there are individual options that you can allow. If for some reason we have to run BGP, we can allow BGP on the tunnel interface and all that. So those are the options from a security perspective. By default, they are all off, but you can turn it on. And then template. So this was the VPN 0. The next is the service VPN. So now, for instance, you want to create multiple service VPNs. You got like segmentation on the LAN side. Inside the service VPN, you can actually define how many types of, like how many service VPNs or the segments you need on the LAN side. Now, in this example, I can keep it for 1, and then I can just add it. Those service VPN will be added on the feature template. Now, I can actually create a template for the VPN as well, for the service VPN. I can name it as service side VPN 1. And then all the information that is related to the VPN 1, I can put it in. If I want to have any static routes in it, if I'm creating a GRE tunnel from these server side VPN. Let me get some power. I think I'm just low. 0. The Mac. What's that? Okay. Yeah. So I just saved this on the VPN side. Then inside the VPN, on the service side, I can add protocols. I can add interfaces. So let's suppose if I want to set up a BGP session, I add a BGP template here, and then name it as global no shutdown. And then all the BGP related information, I can add it into my BGP template, like what's the AS number, what's the router ID that I want to use, and what are my neighbors that are there, what kind of network I want to advertise. So all the BGP related information can go into a BGP template. Okay, I'll just send. Okay. So similarly, there are other protocols that I can create templates for. So all the individual protocol will become their own templates, which will be inherited to the server-side VPN. And at the same time, we can add the interfaces that will be part of those LAN-side VPNs. So basically, again, the construct would be the system-related information that we need to enter, the transport and the management VPN, the VPN 0 related information where we can add the interfaces and the routing protocol. Similarly, on the service side, it's the same workflow. We can add the interfaces, we can add the routing protocols. All those will be individual feature templates that will be inherited into the device. And then once we have the template created, here I have some bunch of templates that are already created. We can simply pick the device. If I want to detach this, and then I can try to, we can simply pick the devices from the list, attach or detach the templates to the click of a button. So once you have the templates built, you need also to attach the devices to it. In this case, I'm actually detaching a device to an already attached templates. It will actually show you on what are the config, what is the delta in the configs that are actually going into the final config. And then after you apply the config, if for some reason there's a fat fingering and you lose connectivity, there's an upgrade confirm timer which will actually revert back the config in case if there's a fat fingering of it. So from a deployment planning perspective, before you bring up any sites, these templates needs to be ready on the vManage. All the values that you are setting it up as the variables needs to be uploaded to the vManage. Once you have those set it up already, the new devices will come up and just inherit those values and those templates, and your site will be just a zero-touch bring up after that. But that work needs to happen prior to actually bringing up a site, the policy and both the template pieces. So with that, that's pretty much it, what we had on the agenda item. If there is any additional Q&A, I can take it. Otherwise, I can take a look at your lab setups as well, like if something is not right for you guys. Cool. Thanks, guys.